Hello, welcome to Math. Show that integral secant x squared dx is equal to tangent x plus c. Show that integral secant squared x dx is equal to tangent x plus c. Now let's write our solution. Let's repeat this integral. Now here we are going to do substitution, okay? So substitution. We will let u equal to secant x, then we differentiate, okay? So u equals secant x. Now here we are going to differentiate, okay? So differentiate. Now when you differentiate this one, we are going to get du is equal to secant x tangent x. When you differentiate this one, we are going to get du is equal to secant x tangent x dx, okay? Okay. Here we are going to divide both sides by secant x tangent x, okay, so that we can get dx, okay? So we divide this one by secant x tangent x and also divide this one by secant x tangent x, okay? So let's write. Now let's divide. Now secant x tangent x dx divided by secant x tangent x, this and this will cancel out and to be left with dx. So this is going to give us dx is equal to du over secant x tangent x, okay? So let's write. Now mind you, we made substitution. We let u equal to secant x. So wherever we see this secant x, we replace it with u. And this tangent x, now remember, using trig identity ratios, 1 plus tangent square x is equal to secant square x. So if we make tangent x the subject, you are going to get square root of secant x squared minus 1. Okay, so wherever we see tangent, we replace it with square root of secant x squared minus 1. And also we know that secant x is equal to u. We know that secant x is equal to u. So wherever we see secant x, we just replace it with u. Okay, so let's write. So here we are having secant square x minus 1, but we know that secant x is what? U. So we will write u here and it will give us square root of u squared minus 1 because secant x is what? U. Okay, so let's write. Now let's put this one into the integrals and let's continue from there. U squared times 1 over u multiplied by square root of u squared minus 1. Now this u will cancel out with this one. It will be left with u over square root of u squared minus 1. Okay, so let's write. U over square root of u squared minus 1. Now here we are going to do another substitution. This is because when we differentiate this one, it can cancel out with this one. Okay, so we are going to do another substitution. Okay, so let's write substitution. We will let m be equal to u squared minus 1. Okay, now here we are going to differentiate. So we just differentiate this one. So differentiate. Now when you differentiate this, we are going to get dm is equal to 2u du. Now when you differentiate this constant, we are just going to get 0. To differentiate this one, we just multiply this by this. That is 2u, then we decrease the power by 1. Okay, so when you differentiate this one, we are going to get dm is equal to 2u du. Okay, let's write. Here, we are going to divide both sides by 2u just to get what? Du. Okay, so divide both sides by 2u. So let's write. Now this one will cancel out with this one and to be left with what? Du. So this one will give us du is equal to dm over 2u. Okay, let's write. Now let's put this one into the integrals, and as usual, let's continue from there. Now I maintain this u because we are going to do cancellation, and I want to show you the cancellation aspect. Okay, so here this u will cancel out with this u, and then we'll write this 1 over 2 outside here, and then we integrate what is inside. Okay, so let's write. Now 1 over 2 integral 1 over square root of m dm. Here we are going to apply the negative index law of indices. That is 1 over a can be written as a raised to the power negative 1. And this square root of m here can be written as m raised to the power minus half. Okay, so let's write. Now, as I was saying, when you apply the negative law of indices, we are going to get m raised to the power minus half, because the law says that a raised to the power minus 1 can be written as 1 over a, or 1 over a can be written as a raised to the power minus half. Okay, so here we are just going to integrate, and to integrate this one, we will add 1 to this one, and then we divide it by what? The power here. Okay, so let's write. Now here m raised to the power minus half plus 1 divided by minus half plus 1. Now to compute this, we multiply this one by this, we multiply the 2 by 1, and to give us 2, and minus 1 plus 2 will give us what? 1. So here will give us what? M raised to the power positive half. Now the same thing applies here. 2 by 1 will give us 2, and minus 1 plus 2 will give us what? Half. So we are going to get m raised to the power 1 over 2 divided by 1 out of 2. Okay, so let's write. Okay, now here, this 1 over 2, this 2 here, will just come and multiply the m raised to the power half on top here. Okay, and remember, m raised to the power half is the same as square root of m. So you just rewrite this one as square root of what? M. And that is going to give us 1 over 2 into bracket 2 times square root of m. Okay, so let's write. Now here, let's open the bracket. Open the bracket. Now when you open the bracket, means we are going to multiply this 1 over 2 by what is in the bracket. Okay, so 1 over 2 times, 1 over 2 times 2 times square root of m. These 2 and these 2 will cancel out, and to be left with square root of what? M. Okay, so let's write. Now we are done with the integration. We have to go back to the x word. Okay, so remember, we know that m is equal to u squared minus 1. U squared minus 1. So we have to put u squared minus 1 back here. Okay, so let's write, but m is equal to u squared minus 1. So wherever you see this m, you're just going to put this one there. Okay, so let's write u squared minus 1. But we also know that u is equal to secant x. Okay, like I said we are going back to the x world or the secant world. So we know that u is equal to secant x. So wherever we see u, we will just put secant x there because we are done with everything and we are going back. Okay, so we are going to put secant x here. Okay, so let's write. So wherever you see this u squared, we are just going to put this one there. Okay, secant squared x minus 1, square root of secant squared x minus 1. Now here, from the previous workings, we saw that tangent x was equal to this, was equal to square root of secant squared x minus 1. So if we have gotten this one, it's a matter of just replacing it with what? Tangent x, because tangent x is equal to square root of secant squared x minus 1. So this one is equal to tangent x. Okay, so let's write. Now we are done with everything. So this one gave us what? Tangent x. It's all because tangent x was equal to the square root of secant squared x minus 1. Okay, so therefore integral secant square x dx equal to tangent x plus c. Now from the workings from above, tell us why when we integrate secant square x dx it gives us what? Tangent x plus c. Okay, all right, that's it. Please, if you like this video, kindly give it a thumbs up, subscribe and comment. Thanks for watching.